Hey guys, this is Coach Lo, and we're back with Lesson 5, Chapter 1. We are going to talk today about angle relationship. So you can write these down in your notebook. As we go, you can pause whenever you need to, of course. All right, let's start with adjacent angles. Two angles that lie in the same plane have a common vertex and a common side, but no common interior points. So I'm going to draw a sketch to the side here. And move those a little bit where we can. All right. So I'm going to go ahead and label these. So I have angle ABC and angle CBD. These two angles, angle ABC, remember vertex right in the middle, and angle CBD, are adjacent angles. They share ray BC as a side. Right? Linear pair, no common sides. Or there are common sides, they are adjacent angles, so it will look just like this, except that they will have the non-common sides heading in the opposite direction. So it looks like this. Start out with a straight angle. So this would be R, S, T, and U. So RST, TSU are a linear pair. That means when I add these two guys together every time, they're going to add to be 180 degrees. So if I start here and measure all the way around 180 degrees there. All right, vertical angles. Vertical angles are formed by two intersecting lines. So let's just draw a random two lines that intersect. We'll number these. Angles 1 and 3 are vertical angles. They are non-adjacent, so they're not right next to each other. And those angle measures would be equal. 2 and 4, vertical angles. Vertical angles are always equal in measure. So 2 and 4 would be equal in measure. 1 and 3 would be equal in measure. All right, supplementary angles are angles that add to be 180 degrees. Going back to the linear pair, not only would RST and TSU be a linear pair, but they would also be supplementary angles. All supplementary angles do not have to be linear pairs. They can be separated from each other, but a linear pair will always be supplementary. Complementary angles are angles that add to be 90 degrees. All right, example number 1, identifying angle pairs. So look at the figure, and I need you to find two acute adjacent angles. So that means they're going to have to share they'll have a common side, they'll have to share a side, and then two obtuse vertical angles. So let's remind ourselves, acute angles. Oh, a cute little angle. Less than 90 degrees. You have to say that, by the way. I want to hear that tomorrow. Cute little angle. And then obtuse, larger than 90 degrees. You have to use those voices tomorrow. All right. So two acute adjacent angles, two obtuse vertical angles. You need to pause the video. Go ahead and do that. All right, now that we are back, let's look at come on now. All right, let's look at these two angles. Let's start with B, BCH. What could be a common angle with BCH that is acute? Is there anything? I have a vertical angle with BCH. It's an acute angle, but I don't see anything that would go with that one, so let's try another one. What about ACD? It is also another acute angle. Is there an adjacent angle with ACD? How about DCG? Those two angles are adjacent angles and their angle measures would be less than 90 degrees. I could also use DCG, GCF. I could also use those two. We could also use some of these tall ones, ABD and DBC. So those aren't the only ones that are on this picture, but just a few examples. All right, obtuse. Obtuse vertical angles. I'm going to go ahead and write here while you're looking for obtuse. If you need to pause the video, you can. All right, obtuse vertical angles, larger than 90 degrees. All right, so let's see if we can find a couple of those. How about BCD? Now, the next angle I draw has to share one of those two sides, right? So how about, oh, we need vertical, my bad, not adjacent. So they have to follow along the same line. They have to be intersecting lines. So how about that one? Those two would be in common. And then how about, let's see, G would go there. Those two would be in common. So you can kind of see how they would land right on top of each other, intersecting lines. Let's draw it another way here. There's two lines that intersect. You can see their intersection point there with a different color. Vertical angles, we could say BCH and CDG. Now the question is, are those obtuse? And they are not. They're acute. All right, so let's look at the other ones. BCD, HCG. Yep, those are obtuse, definitely. So angle BCD and angle HCG. Awesome sauce. All right, let's keep going. All right, angle measures. Find the measures of two supplementary angles if the difference of the measures of the two angles is 32 degrees. All right, here's what we know. We know that these two guys add to be 180 degrees. Supplementary, that's exactly what that means. All right, so that means the measure of angle A plus the measure of angle B has to add to be the sum 180 degrees. All right, we also know that the difference of the two measures is 32, which means the measure of angle A minus the measure of angle B equals 180 degrees. Or you could write it the other way. Measure of angle B minus measure of angle A equals 180 degrees. So not the only way you have to write it. All right, so let's just go ahead and say that the measure of angle A is x. That would make the measure of angle B, I said angle B and I wrote angle A. That would make the measure of angle B, this is awesome. Okay, we're just going to keep going. That would make the measure of angle B, love technology, measure of angle A is x, measure of angle B is 180 minus x. Remember what we had, the measure of angle A plus the measure of angle B equals 180. If I say that this is x, and I solve for measure of angle B, that means I'm just going to scoot this x to the other side, subtract x from both sides, and now I have 180 minus x. So here's what I'm going to do. I'm going to take I know the difference between those two. I'm going to take x and I'm going to put it in for the measure of angle A. And I'm going to take this stuff for angle B and I'm going to put it right here. Then we're going to have a nice little equation that we can solve. All right, so 180 minus x minus the measure of angle A. All right, so notice what I did. I put x where the measure of angle A was before, and I put 180 minus x where the measure of angle B was before. And that's equal to 32. Now go ahead and solve that equation for me. All right, now that you've solved the equation, I'll go back through the steps with you. I'm going to slide 1's in front of these. So 1x, negative 1x minus 1x is negative 2x, and that's equal to negative 148 when I subtract those two. So x is 74, which means the measure of angle A is 74. And since they are supplementary, they have to add to be 180. So 180 minus 74 is 106. So the two angle measures are 74 and 106. Just by the picture, it looks like this one is larger than a 90-degree angle. It would be obtuse, and this one would be acute. All right, perpendicular rays. When I have two rays line segments that are perpendicular, they make 4 right angles. Symbol for right angle looks like this. Awesome. So line AC is perpendicular to line BD. You can also note it like this with a little perpendicular symbol. So perpendicular symbol looks like an upside down T. All right, we want to find X and Y where lines D and G are perpendicular. Pause the video if you need to work this out. All right, so line D, line DG, line BE are there. What do I know from that? Well, I know that they form right angles at the intersection point. So all of those are right angles. I can set up a couple of equations. I know that 4x plus 2x equals 90 degrees. That's right here. And I also know that from here, 5y plus 20 also equals 90 degrees. Solving those two, 6x equals 90. Dividing both sides, that was putting like terms together. Dividing both sides by 6, x is 15, which would make this angle, if you have to find the angles, 2 times x, 30 degrees. This one 4 times 15, 4 times x, or 60 degrees. 30 and 60, 90. Good to go there. All right, this one 5y equals 70, subtracting 20 from both sides. Dividing both sides by 5, y is 15. So if I plug it back in here, 5 times 15 is 70 plus 20 is 90. Bam. Good to go. All right, next one. Determine whether each statement can be assumed from the figure and explain. So from the figure, BFC and AFG are complementary. No, we do not know that. They are not congruent. I mean, they are congruent, but that's all we know. We don't know a measure. We would need to know a measure like it would have to be 45 degrees for those to be complementary because they have to add to be 90. All right, next one, DFA, right, DFA and AFG are a linear pair. So they are adjacent angles and they do have rays heading in opposite directions. So yes, they are a linear pair. Their non-common sides are opposite rays. All right, and then C, DFC and FBC are complementary. Yes, they are. They are adjacent angles and they form together a right angle, add to be 90 degrees. All right, guys, good job today. Talk to you later. Bye.